So in the last lesson, we talked about question number 3, where it talked about in questions numbers 1 and 2, we created a table and a graph to represent Shauna's savings situation. We wrote a rule right here, A equals 10T, where A represents the amount of money saved and T represents the time in weeks. Now, each week, the amount of money in Shauna's savings increases by $10, which you can see here. So where do you see this constant rate of change in each representation when we're talking about the graph and the table? Well, again, if you look at the at the graph, every time we move over 1 week, the amount of money in her savings goes up by 10. At 2 weeks, it's at 20. At 3 weeks, it's at 30. At 4 weeks, it's at 40, and so on. So every time that we move over in time, 1 week, the amount of money in our savings goes up by 10. And in the table, of course, when we switch as we go down the table in weeks, well, we're adding 10 here, right? Here's our constant rate of change. Every time that we move down a week, it adds $10. So it's easy to see in the table and in the graph where this constant rate of change is in the representation. Okay, so let's move on to the next question. Manuel worked all summer at an amusement park and saved $1,050. Okay, you can see that there and there in the table. At the end of the summer, he stopped putting money into the account and instead began making weekly withdrawals. Manuel made this table to represent the activity in his account. Describe precisely what is happening to the amount of money in Manuel's savings account. And then the next question, this is what threw me at the end of the last lesson. Does Manuel's savings amount vary directly with the time in weeks worked? And the worked part shouldn't be there. It should just be the time in weeks, because it's not the time in weeks worked, because he's already quit working. This is the end of the summer, and now he is stopped putting money in from his work, and now he's taking money out. Okay, making weekly withdrawals. So this is what they want us to do. They want us to describe precisely what is happening to the amount of money in Manuel's savings account. And is it a direct variation with the time in weeks? Okay. So let's have a look, right? As we move from, okay, yes, you're absolutely right. As we move from the start to week 1, how much did the amount of money in his savings? It looks like it's dropping, right? And by how much? It looks like it's dropping by $50. Is that the same every time? Looks like it. It's going down by 50 every time, right? We're subtracting 50 every week. Looks like. Okay. So then we can say that the amount of money in Manuel's account drops by $50 per week. Money in his account is reduced, that's better, by $50 per week. Okay. Oh, question mark. There we go. Perfect. Now, does Manuel's savings amount vary directly? Okay. That's a great question. Does it vary directly with the time and weeks that he worked? Well, what do we mean when there's a direct variation, right? Now, in order for that to happen, it would have to be a proportional relationship, right? Doesn't there have to be a proportional relationship in order for the output to vary directly with the input? So is this a proportional relationship? To help us answer this question, right? And somebody says, no, it is not a direct variation, right? Whoops, hold on a second. Got to type there. Perfect. Okay. It does not. Exactly. It does not vary directly with the time. Okay. Sorry, I don't need a comma. Because a proportional relationship does not exist. Oh, no. Okay, so it doesn't exist. And yes, you're absolutely right, because if we were to graph this line, it would not pass through the origin. When you get down to when we're looking at 0 weeks, right? When we're looking at 0 weeks, we should have $0 if it is varying directly, right? If it varies directly, we would have 0, 0, but it doesn't. There's money there at the beginning, so it doesn't vary directly because there's no proportional relationship. Very nice, right? Even though the rate of change is constant, right? The rate of change is constant, but this is not. This is a non-proportional linear relationship. Very good. All right. Well, let's look at question 5 then. Now, we'll go back up here slightly. There we go. In the table, you can see 6 weeks of Manuel's spending. So let's study the pattern, right, in the table, and then write a linear function that you could use to find out how much money Manuel still has in his savings account after 10 weeks or 20 weeks. So I guess what we should do, right, is we should come up with an equation to represent the situation. Correct? So let's let we're going to let y equal the amount in his savings. And we'll let x represent the number of weeks. Oh, come on. Come on. It doesn't want to let me draw my oh, there we go. Number of weeks. There we go. All right. And so if we were to write this out as a linear function, the amount of money that he has in his savings, right? Now we could write it like this, is 1,050, because that's where it started, right? But then we would subtract $50 for every week that he is, that he's taking the money out. Now, that's great, except this isn't in slope-intercept form, which, that's what we've been practicing. So what you could say is instead, you could say, well, it's the amount of money in his account is $50 withdrawn for every week, starting at 1,050. So either one of those is absolutely correct because they are interchangeable like that. Okay. Now, we still have to figure out how much money he would have. But we don't. That's all we needed for question number 5 was to come up with the equation, and so we're good with that. So let's find out then in the next one. And that's weird because they don't actually ask. It just says write the linear function rule. So great, we wrote the rule. We don't actually have to come up with how much money he would have in 10 weeks or 20 weeks. But let's take a look at question number 6. Assume that Manuel's spending rate remains the same for several more weeks. So that means that the equation would still be the same, right? Negative 50x plus 1,050. Use your rule to calculate how much money Manuel will have in his savings account after 15 weeks. Well, that seems fairly easy to do, right? Because we know they want us to talk about 15 weeks. So where would we put that into our equation? Right? Wouldn't we, if doesn't X represent the number of weeks? So all we would have to do is substitute 15 for that. So let's do a different color just for fun. Y equals negative 50 multiplied by X, which in this case would be 15 plus 1,050. Okay, so negative 50 multiplied by 15 is negative 750 plus 1,050. And so now all right, well, y equals, there we go, negative 750 plus 1050. Well, that's $300. So how much money will he have left in his account? Well, he'll have $300 in his account. Okay. No questions so far. So far, so good. Doing well. All right. Just a second here. I need to take care of that. There we go. All right. So now, based on this, we want to make a scatter plot of the data that is shown in the table from question 5. And then we're going to graph the function rule through that. So the scatter plot, remember, scatter plot means dots, okay? Scatter plot means dots. But then when it says graph the function by drawing a line through the points, then graphing means you're drawing a line. So make sure that you're graphing by drawing a line. The other thing I want to caution you, make sure that you label your axes. This is your x-axis. This is your y-axis. But what do they mean, right? This had better be the number of weeks. And this will be the amount in his account. In dollars. So make sure you label your graph. And we are almost out of time. So I'm going to stop my recording. Just make sure that you label everything, make your scatter plot with your dots, and then draw the line through the dots based on how you set up your graph. And I firmly believe that the rest of this assignment for topic 8, block 8, you should be able to sort out on your own. We can talk about any questions you might have tomorrow during class, but I'm going to let you finish